This audiobook of the original America Burning was produced by the firefighter podcast Combustible. More details on this project can be found online at www.combustiblethepodcast.com. The audio for this recording is consistent with all copyright rights and permissions associated with America Burning and is not affiliated with or endorsed in any way by the federal government or the U.S. Fire Administration. Chapter 12. Transportation Fire Hazards. Ever since man learned there was a better way than a pair of feet to get from here to there, he has developed a propensity for not getting there at all. As he has honed his technology of transport, he has also dropped from the sky like a lead weight, sunk to the bottom of the sea, tumbled from the sides of mountains, and met in disastrous collision his fellow man traveling in the opposite direction. In the process, he has managed to destroy a considerable amount of the wealth that he felt it necessary to carry from here to there. He has also destroyed human lives. Fire is not the inevitable consequence of a transportation accident, but in an age of combustion fuels, it is a frequent accompaniment. In 1971, about 4,260 Americans, or about one-third of all who died in fires, lost their lives in burning planes, trains, ships, or motor vehicles. The majority of these were lost on the highways. The National Fire Protection Association estimates that, in that year, 521,800 transportation fires caused property losses exceeding $332 million. See Table 12-1. That was 20,950 more fires and $63 million more in losses than the year before. Several factors have contributed to the growth of transportation fires. First, a citizenry growing in affluence and mobility is using transportation as never before. During the 1960s, passenger miles on U.S. airlines more than tripled, from 34 billion passenger miles in 1960 to 123 billion in 1970. Motor vehicle registrations went from 74 million in 1960 to 108 million in 1970, an increase of 46%. A second factor, related to the first, is the nation's rapidly increasing consumption of goods, which requires more transport vehicles to travel more frequently to meet the demands. Third, hazardous materials which once traveled solely on one mode of transportation are now often exposed during transit to two or more, for example, piggyback truck rail arrangements and containerized shipping, increasing the amount of handling and straining the capacities of the containers. Fourth, new materials and new forms of old materials, such as liquefied petroleum gas, are being introduced at a rate that challenges regulatory measures and firefighting techniques to keep up. Transport of hazardous materials. About 10,000 new chemical products are developed every year. Most never reach the commercial market, some do. And of those that do, there are some that can present severe fire threats as they are moved from place to place. Real facts about the frequency and causes of transport fires involving hazardous cargoes are hard to come by. Within the Department of Transportation, such agencies as the Federal Aviation Administration, the Federal Railroad Administration, and the Federal Highway Administration investigate accidents in their respective areas of concern. In a study of reporting systems issued 4 years ago, the National Transportation Safety Board, another arm of the Department of Transportation, complained of the parochialism of accident reports and the fact that they have not contained information appropriate in character, depth, and detail to have much value in preventing hazardous accidents in other modes. Some of this is changing. The Office of Hazardous Materials, still another Department of Transportation entity, has developed a system for receiving, storing, and retrieving information on hazardous materials accidents. The National Transportation Safety Board has the duty to investigate causes of transportation accidents, excluding aircraft and marine accidents. Yet in 1971, the Safety Board reviewed and issued only 22 reports of separate rail, highway, and pipeline incidents. The Commission recommends that the National Transportation Safety Board expand its efforts in issuance of reports on transportation accidents so that the information can be used to improve transportation fire safety. Despite the absence of complete statistics, some generalizations are possible. There are more fires and explosions involving tank vehicles during loading and unloading than during actual transit. Routine transportation presents little hazard. It is the interruption to smooth transit that causes accidents. Regulations concerning the transportation of hazardous materials lag behind current needs. As one commentator has put it, the regulatory system is part of the problem and not part of the solution. In addition, the hazards that are covered can be bewilderingly complex. Whether it is the state police, another enforcement authority, or the fire department that responds to an emergency, rudimentary knowledge is not sufficient. Complications are often present. Physical properties. A liquefied gas, for example, may have widely different fire and explosion hazards from those that exist when the fuel is shipped in a vaporized form. Mixture of hazards. A material may well be toxic, flammable, and reactive all at the same time, yet marked for only one of the hazards. Similar names, divergent hazards. One material with a name quite similar to another may present quite different hazards. Firefighters and the public alike would also be better served if trucks, tank cars, and other vessels for transporting hazardous materials carried clearly visible, readily understandable markings indicating the hazards therein. The two most universally recognized means of identification of hazardous materials are the National Fire Protection Association's 704M system and the Department of Transportation's Hazardous Information System. While the systems are not dissimilar in the important respects, the nation would be better served if a single system, incorporating the best aspects of each, were adopted universally. The Commission recommends that the Department of Transportation work with interested parties to develop a marking system to be adopted nationwide for the purpose of identifying transportation hazards. In carrying out this recommendation, the Department of Transportation should seek the cooperation and agreement of the Department of Labor, which, under the Occupational Safety and Health Act, is charged with developing a labeling system for hazardous materials for protection of employees. Since those who must utilize the information gained from these markings often must do so under poor lighting and hazardous conditions, representatives of the fire services should also be consulted. The complexity of hazards complicates firefighting. While spillage of a highly flammable liquid into a stream may actually reduce hazards, spillage of a toxic liquid into a stream creates a new and major problem. Chemical foams effectively extinguish some tank fires, but are rendered useless if certain solvents are present. For their own safety, firefighters need to know the particular hazards and proper tactics to use with each material, so that they can cope with what is likely to happen next. In a word, then, firefighters must be well informed about the hazards they are asked to deal with. While the National Fire Protection Association, state firefighter schools, and some industry representatives have attempted to educate fire departments on chemical hazards and proper tactics to use on transportation fires, the results have been very uneven. Training is likely superior in urban areas, but trucks and trains cross vast patches of rural America, at greater speed than in urban areas, and where training is likely to be minimal. The Commission recommends that the proposed National Fire Academy disseminate to every fire jurisdiction appropriate educational materials on the problems of transporting hazardous materials. Even with adequate labeling and considerable training, fire departments may face new or unusual hazards in transportation accidents for which their knowledge of appropriate handling is, at best, uncertain. In such instances, they should be able to telephone for advice from a source knowledgeable about the particular hazard. The Chemical Transportation Emergency Center, Chemtrack, of the Manufacturing Chemists Association is a long step forward to meeting this need. By tapping its own resources and those of others, such as DOT's Office of Hazardous Materials and the Environmental Protection Agency, it is able to provide instant information for handling emergencies involving hazardous substances. The full potential of this system will not be realized until an adequate labeling system tells fire departments exactly what is inside the containers involved in accidents. The Commission recommends the extension of the Chemtrack system to provide ready access by all fire departments and to include hazard control tactics. The hazard control tactics must come from joint efforts of the proposed National Fire Academy and representatives of the Manufacturing Chemists Association. The public, too, should become more aware of the risks in accidents involving hazardous materials. An incident that happened near Waco, Georgia in June of 1971 illustrates the importance of this. As a result of an accident, a truck carrying 25,000 pounds of dynamite caught fire. Cars stopped and people got out to watch. The driver, who escaped the fire, shouted to them to get away, but to no avail. 6 people died and 33 were injured when the explosion came. The awareness can be attained in many ways. Public fire safety educational materials should contain pertinent information. Basic markings, once one system is adopted, can easily be included in school fire safety education. Groups such as the American Association of Motor Vehicle Administration, the American Driver and Traffic Safety Education Association, the American Automobile Association, the North American Professional Drivers Association, and the National Safety Council can, if given the proper information, included in literature going to their audiences. Interstate, and in fact most intrastate transport, can be effectively controlled by the Department of Transportation, but the system sometimes breaks down at international borders. Loading and unloading sometimes occurs in streets and lots because the Bureau of Customs doesn't have the proper storage facilities. To correct this situation, the Commission recommends that the Department of Treasury establish adequate fire regulations, suitably enforced, for the transportation, storage, and transfer of hazardous materials in international commerce. These efforts must be coordinated with local fire services. Motor vehicle safety. The problem of transporting hazardous materials is dramatic, and failure of the system often causes large losses of life and property in a single incident. However, fires in motor vehicles cause almost 35% of all fire deaths in the United States. In fact, more than 450,000 fires occurred in cars and trucks in the United States in 1971, causing upward of 3,500 deaths and average losses of $200 per fire. That same year, the Bureau of Motor Carrier Safety received 729 reports of truck accidents involving fire. These accidents caused 132 deaths, 309 non-fatal injuries, and $7,831,728 in property damage. For the truck accidents, principal ignition sources in declining order of frequency were collision impact, defective wiring, hot tires, and defective or hot bearings. Fires originating in cargo spaces were the most frequent, followed by those originating in other vehicles or objects, and those starting at tires or wheels. Records kept by Oregon's State Fire Marshal indicate that the most frequent ignition sources in automobile fires are backfires, electrical short circuits, hot mufflers and exhaust pipes, smoking materials, and incendiarism, in that order. The materials first ignited are gasoline and other flammable liquids, electrical insulation, and upholstery. A number of organizations, such as the National Safety Council, the American Trucking Association, and the National Fire Protection Association, have attempted to educate drivers and trucking companies to high standards of fire safety in the use and maintenance of motor vehicles. Power to prescribe safety features and levels of safety-related performance resides with the National Highway Traffic Safety Administration, established by the Highway Safety Act of 1970. In January 1971, that administration published a flammability standard for the interior materials of passenger cars, trucks, and buses to take effect September 1, 1972. The Traffic Safety Administration also asked the Oklahoma University Research Institute to evaluate the new standard. The institute found the standard lacking in that it requires too mild a test to achieve a significant reduction in property loss, much less injuries or fatalities, from vehicle fires. All that the standard accomplishes, the institute's report said, is to discourage use of new materials for vehicle interiors, which are more flammable than those currently employed. Since gasoline spillage is a common cause of vehicle fires, the location, construction, and security of fuel tanks are important design features for fire safety. The most severe losses in terms of both life and property occur from fires following rear-end collisions. Next in importance are rollover accidents, followed by front-end collisions. Fuel tanks for passenger cars must meet a federal standard, which specifies a fixed collision barrier test and the allowable amount of fuel spillage from the tank and its connections in the test. Somewhat more stringent requirements are imposed on large trucks and buses. Studies made for the Department of Transportation have indicated that the current procedure is not adequate to evaluate the performance of a car's total fuel system in a fire situation. Studies by the Cornell Aeronautical Laboratory have shown that while a mid-vehicle location for a fuel tank is probably best, location alone is not the total answer to the fire problem. Improvements can come only through a consideration of the entire system: fuel tank location, fuel line, electrical system and exhaust routing, and configuration of the surrounding structure. Consideration must also be given to the evaporation emission control devices installed on all cars in recent years. The indications, then, are that motor vehicles, especially cars, are not as fire safe as modern technology would allow. Improvements could be made in design and materials without significant additional costs. The Commission recommends that the Department of Transportation set mandatory standards that will provide fire safety in private automobiles. Both materials and structural design should be considered in these standards. Aircraft fire safety. On December 8, 1963, a Pan American Airways jet exploded and burned near Elkton, Maryland, killing all 81 aboard. The frightening aspect for passengers contemplating such an occurrence is that there is no escape, no running from the scene as on land, no climbing into a lifeboat as at sea. Yet fire is the greater killer when it happens after a crash landing. There have been numerous instances when the impact of the landing did not kill passengers, but the ensuing fire did. One such accident cost 43 lives when a commercial aircraft crash-landed near Salt Lake City in November of 1965. From the standpoint of dollar losses, the most serious fires occur at airports and in hangars, usually during the course of maintenance operations. A spectacular fire of this sort occurred in April of 1969 at the Mercer County Airport, New Jersey. Before it was discovered, the flames were 25 feet high. Before it was contained, it had destroyed 49 aircraft, mostly of the single-engine type, 13 helicopters, a large hangar, the passenger terminal facilities, and the offices of the airlines for a total loss of over $3 million. Considering the many materials available to burn, propulsion fuels, hydraulic oils, lubricating oils, and ordinary combustibles and plastics, and the many sources of ignition, electrical, contamination of oxygen lines or valves, lightning and electrostatic charges, hazardous cargoes, and human carelessness, and the many ways an ignition source can come in contact with the combustibles, it is obvious that there are a large number of potentials for disastrous fires in the relatively confined space that constitutes the aircraft environment. There are a number of areas in which research and development could improve the fire safety of aircraft. Reduced chance of ignition. The fuel tanks, the fuels used, and the interior materials are the critical considerations in efforts to reduce the likelihood of fire in aircraft accidents. Increase the chance of survival. Once a fire has started, the buildup of poisonous fumes and heat is dependent on many things, including compartmentation, ventilation, and materials used. Standards of construction must consider not only how easily something can be ignited, but also the effect on survival once it is ignited. Detection and suppression of fires. When on the rare occasion fire occurs during a flight, detection and suppression are normally swift and effective. Aircraft fires during servicing and maintenance are often not so efficiently dealt with. Early automatic detection and suppression systems for parked aircraft, including better fire suppression agents, seem to be needed at many airports. Presently, research on various aspects of aircraft fire safety is scattered among several federal agencies, both civil and military, and aircraft manufacturers. Much research, not specifically connected with aircraft fire safety, will nonetheless have a bearing on future improvements in that field. Coordination of these research efforts is important. First, to ensure that research priorities reflect the scale of needs for aircraft safety, and second, to promote the transfer of technology among the many segments of the aircraft industry and from outside the industry. Many fire chiefs express considerable doubt that they can save lives in an aircraft crash if fire erupts before suppression forces arrive. Their fears are supported by Federal Aviation Administration records, which show that of the 57 air carrier accidents during the decade 1959 through 1968 involving ground fire and fatalities, only 13 occurred at airports and thus within the reach of airport firefighting equipment. In only one of these 13 cases were firefighters able to rescue passengers. The chief emphasis in aircraft fire safety, therefore, will have to be improved design of airplanes and continuation of the careful operation of aircraft that has resulted in an admirably low accident rate for commercial aviation. Still, much can be done to improve the firefighting capabilities at airports. The National Fire Protection Association, the Federal Aviation Administration, the Airline Pilots Association, and the International Civil Aviation Organization are upgrading standards for airport firefighting. Many airports lag behind current standards. It would be appropriate for airport authorities to review their fire suppression and rescue needs, to produce plans for coordinating the firefighting resources of the airfield and surrounding areas, and to set up capital improvement budgets to bring their firefighting capabilities up to NFPA, FAA, and ICAO standards. The Commission recommends that airport authorities review their firefighting capabilities and, where necessary, formulate appropriate capital improvement budgets to meet current recommended aircraft rescue and firefighting practices. We recognize that a firefighting capability adequate to handle a major disaster is expensive, particularly in terms of manpower, considering the rarity of fire accidents. There are available, however, multiple turret fire vehicles which require smaller crews than the several trucks they replace, and progress is being made in the development of automated apparatus for airport fire safety. Marine fire safety. The position of the Coast Guard in maintaining a high level of marine fire safety is a difficult one. Many factors work against them. Long experience in handling hazardous materials by crews and longshoremen can lead to complacency and carelessness. Pushed by schedules and financial incentives to unload quickly, shippers often fail to use the expertise of chemical tankermen who are certified by the Coast Guard, or marine chemists who are certified by the National Fire Protection Association. Since the incentives are often contrary to good fire safety practice, the Coast Guard needs the support of all who can help. Attention should be called to the fact that the Department of Labor has safety responsibilities for the shipbuilders, repairers, and longshoremen. The presence of increasing amounts of high-energy fuels and other hazardous substances passing through ports demands special attention. The Commission recommends that the Department of Transportation undertake a detailed review of the Coast Guard's responsibilities, authority, and standards relating to marine fire safety. Railroad transportation fire safety. With 200,000 miles of main track lines, the nation's rail network is vital to the economy. A fire accident that incapacitates even a small portion of the rail system has an effect far beyond the actual scene of the accident. An accident can be a local disaster if hazardous materials are involved in the fire. Usually, the fault is not with the materials themselves. In January of 1969, 15 exploding tank cars wreaked havoc in Laurel, Mississippi, all because of a defective wheel on one of the cars. 3 weeks after that incident, a misaligned track derailed a train passing through Crete, Nebraska, and derailed cars struck a tank car loaded with anhydrous ammonia standing on a siding. Escaping ammonia gas killed 6 persons and injured 53. In both instances, the cause of the accident was a mechanical failure. The results were thermal and toxic nightmares. Chronic problems with railroads are fires along rights of way, usually started by brake shoe sparks or hot carbon sparks from diesel stacks. In 1970, there were reported 6,645 such fires in or near forest lands. Unreported thousands of fires burned grass and croplands. Responsibility for preventing fire accidents must reside with the railroads themselves. Sound maintenance practices are well known but often not followed. Rights of way should be well maintained, kept free of flammable materials, and inspected frequently. Malfunctioning equipment should be quickly removed from service. The Commission recommends that the railroads begin a concerted effort to reduce rail-caused fires along the nation's rail system. Equipping non-turbo locomotives with exhaust spark arresters, reducing the frequency of mechanical and rail failures, adopting braking procedures and equipment designed to prevent hot brake shoe fragments from spewing, training crews in fire suppression, and providing trains with appropriate fire suppression tools are measures for consideration. San Francisco's Bay Area Rapid Transit, known as BART, has signaled the beginning of a new era of mass transit construction in the United States. As these systems are developed, and as existing systems are modernized, there will be a need to protect the lives of those who must travel through tunnels and over elevated tracks. Tunnels especially can be traps. In a Boston subway tunnel fire in February 1973, 1 person died and more than 100 had to be treated in hospitals, mostly for smoke inhalation. In a special study in 1970, the National Transportation Safety Board found that no safety conditions were being attached to Urban Mass Transportation Administration grants for rapid rail transit systems. In support of the board's findings, the Commission recommends that the Urban Mass Transportation Administration require explicit fire safety plans as a condition for all grants for rapid transit systems.